Oh, thank you everybody for coming. I'm gonna impromptu step in for Paul since he has stuff come up. And I'm here and I know how to do this because I do go one. So I don't need to do much. I can't go through his whole rigmarole. I don't have Paul Quadrivive. Usually spend a little bit of time to start asking if people are doing anything interesting. So I'm gonna, in honor of Paul, who's not here, is anybody doing anything interesting that they Kubernetes or something they wanted to bring up, some new feature they're excited about? I think so. No, it's yes. You there.
1.33 finally has a feature gate where you can make crash loop backoffs, not be such a hard-coded long time.
Oh, that
makes me very happy.
That's it, like the level, or is there some sort of config? Like
I didn't look super close. I just saw it as a highlight. So I was like, yes.
Like just incur the cost of like 5-minute max back off or whatever. Yeah. Cool. No, that's
We have stuff like worker pods where it's like Chrome is running in a separate container and it's gonna crash.
Yeah.
But I don't need to wait for it to. It's not a race condition. There's not. But you can't override it.
no, it's I think it was Kelsey Hightower who like predicted that it was going to get boring, and he was like, it's one of those almost. There was a discussion about whether Go was getting like lack of use or not getting an uptick anymore because it's become so stable and boring. Like, and is it sort of that point where like used to be we talked about bringing new features. Now there's cron jobs in the new version, or there's this entire new gateway. Now it's like, not saying it's not interesting, but you can tweak this one number in the config now. Like, well, it's a new version today. That's cool though. So Paul would be happy. We had a little Kubernetes small talk. I won't take up any more time. I'm gonna jump up here. All I want to do is introduce Ben. Ben's a really smart guy. He's the guy that really convinced me to the error of my ways when it came to API design. We had our internal dev conference a while back. I stood up and I had a talk all prepared about how I thought API should go, and Ben did one before me and basically invalidated all my ideas. And I've learned why resource-oriented design and Google's AIP system is actually got you could argue against, but there's a lot of smart stuff in there. And I've recently been dealing with some pain points in my own old APIs, my own design. So I don't know if he knows as much about StarRocks as he does about API design. Really confident in. So I'll kick it over to Ben. Thanks, Ben.
Thanks. Yeah, so I'm going to talk about how we are using and running StarRocks Beeve. So I know this is the Kubernetes meetup, but
it's a cloud native meetup too. It's kind of
right. This is going to focus very heavily on StarRocks, and really the connection is that we're running StarRocks on Kubernetes. So, you know, it's cool technology, cloud native, Linux Foundation technology that we can run on Kubernetes and take advantage of a lot of features there. So anyways, tell you a little bit more about myself. So I started my career at this company called Savannah River Nuclear Solutions, worked on this project called the Mobile Plutonium Facility. Talk to me about it later if you're interested, but it was a really cool project. Spent 4 years working at BYU doing a library search engine. I like to tell people that I gained experience doing search at BYU, but really what I gained experience doing was you know, data pipelines, data engineering, and ETL type of stuff. You know, that was most of my focus, you know, as opposed to Elasticsearch and such. So did a little bit of that, but yeah, I've been at Weave for 4 years now. I'm on the messaging teams. That's not, you know, Kafka, NSQ, NATS. That's SMS and email type messaging. So we handle all of the text-based communication for our customers. So, yeah, and then just a little bit about me. You know, I like doing hiking, camping, anything outdoors. I do some woodworking as a hobby. And then I love like the factory simulation games like Satisfactory and Dyson Sphere Program. Those are kind of my jam right now. So yeah, just a little bit about me. So, all right, StarRocks. Get into it. What is it? This is taken from their website, so it's a next generation blazing fast. You know, they want to draw your attention there. Massively parallel processing database for real-time analytics. So yeah, their big thing is sub-second queries at scale. Originally, it was born out of Apache Doris. Since the fork, my understanding is that StarRocks has completely rewritten the query engine. So there's not a whole lot shared in terms of, you know, kind of exactly what's going on there, but that's kind of where it came from. It is open source. It's part of the Linux Foundation, so that's really nice. Apache 2.0 licensed, I think. So that's right, Linux Foundation. It uses the MySQL protocol, which is a small point against it, in my opinion, unfortunately. But it does mean that it has good support. So you can connect right up to it using anything that works on it. So. A little bit about the architecture. So this is interesting. StarRocks actually has two different ways that you can run it. This first one is called shared nothing. And what this means is that, so both ways of running this, you have these front end nodes. These are kind of what run the coordination for your queries. They also act as load balancers. So you always have a pool of front end nodes. And then in this configuration, you also have a pool of backend nodes, but you also have local data on each node. So here, you know, this is kind of your traditional like horizontal scaling database. Storage and compute are coupled. If you're running out of one or the other, you have to scale up both in order to get more. So that's how that works. There's some advantages to this, to running it this way. But the way that we have opted for is called this shared data mode, where instead of, so you still have the front ends doing the load balancing and coordination, but now instead of backend nodes, you have these CN, those container nodes, or I think is what it stands for. They do have some local storage, but it's only a cache. The actual source of truth for all of the data is going to be in some sort of object storage, S3, GCS, whatever. So if you're running out of compute capacity, you know, your nodes are all hitting near 100% CPU utilization, then you can just start adding more nodes, and they'll pull the data out of object storage and start running queries against it. So that's how that works. One of the really cool, like, this is one of the coolest features that StarRocks supports, in my opinion. There's this thing called data lakes. So in addition to doing this, where it can access its own data in object storage, you can actually add multiple catalogs, and you can say like, okay, well, we have the data that's stored here locally in StarRocks, but also I want to be able to query this Parquet or this iceberg table that's being stored in GCS. I also want to hook this up to, like, I think that you can hook it up to Elasticsearch or Apache Solr. You can hook it up to Postgres, MySQL, trying to do some federated analytics, or even just just start pulling data in from those other systems. That kind of is an ingest process almost. So here at Weave, we have this data lake that we've been working on that's built on iceberg tables. And one of the very first things that we did with StarRocks was we hooked up StarRocks to that new data lake. And so, well, okay, I want to see what I can do here. And I was able to join directly you know, this table that was over here in, you know, stored in a completely different system that I had access to in StarRocks. I was able to join it up directly with this data that I had in StarRocks and do some really awesome analytics, and answer some questions that we had about, you know, some product data and usage that we were interested in. As far as data lakes, there's a bunch supported. There's a list of them here: Hive, Iceberg, Hootie, Delta Lake, JDBC. Anything that has a JDBC driver, you can hook up to it. So that opens this up to, you know, about anything relational. Elasticsearch, that is on there. Max Compute, that's an Alibaba cloud thing. And Apache Kudu. And since I started working with StarRocks, it's been a year or so. A couple of these are new. So this is, you know, kind of actively developing. They're adding support for more things. Kind of a nice thing to see, you know, see active development on projects like this. Deployment. So I talked about the architecture that we chose, which was, you know, the shared data architecture. StarRocks actually provides several ways that you can deploy it, though. There's the manual option, which obviously nobody really cares for. That means, you know, spinning up each of those components and configuring them yourself and making sure that they can communicate with each other and all that. There's a Helm chart that you can run against your Kubernetes cluster. I don't know if we've actually tried to do that before. I'm not 100% sure, but it should work. And then the route that we've opted for is they do have a Kubernetes operator. So, you know, we have the operator deployed and we just create one of their CRDs for a Kubernetes cluster, and it goes and it takes care of everything else for us. It's actually super slick. It supports upgrades, minor version upgrades, and then the latest minor version to the next major version also. So yeah. And then finally, the last way that you can deploy it, which is basically if you're going to get a support contract from the company that is behind StarRocks, they're probably going to push you towards this Seller Data Bring Your Own Cloud. Seller Data is the name of the company. Basically, they run a nice interface, and you can hook up your own cloud account to that interface and start provisioning Stellar data clusters. They're StarRocks clusters, but there's some niceties there. I don't know everything involved in that, but that is an option. So, all right, I want to talk a little bit about our use cases. So these are some very high-level system diagrams, and the first one is very, very old. It's what we were coming from. So it used to be that analytics, we have we have an analytics product for our customers. And it used to be that there were 9 Postgres databases dedicated to this. There was a ton of cloud spend to be maintaining these 9 databases. And the analytics service had to know, okay, here's where to go for this data, here's where to go for this data, here's where to go for this data, etc. So I don't remember how large these nodes were, but I think they were sizable. So I do remember that they were quite pricey, was the big thing. But we were able to take this and completely replace 9 Postgres instances with a single StarRocks cluster. This is a 4 or 5 nodes The nice thing about it is that the analytics service became a whole lot simpler. You know, it doesn't have to know where everything lives. It can just say, hey, StarRocks, I want to query this data. And it queries it and returns it. And if we ever run out of compute capacity on the StarRocks cluster, well, we just go from 5 to 6 nodes. So this was really awesome. This was like a huge win. We were able to get, you know, a vastly simpler architecture and some pretty good cost savings out of it too. The next thing is messaging. So this is my domain. This is what I work on. Our old automated messaging service was a mess, to say the least, but and this really is an oversimplification. There were about a dozen services up in here, all interconnected to these different things. But we had a bunch of services, each with their own Postgres database that you know, we would call some APIs on each of these services, and then we would basically join everything up in memory by, you know, by doing these different API calls. It worked. It got weaved to where we were about 2 years ago. And so it was a great piece of technology, but it was getting very dated, especially after being updated so many different times. So what we did is we replaced it with a data warehouse technology. You might have heard of Vertica. But it vastly simplified the architecture of automated messaging. And we've been pleased with Vertica in some ways and very displeased in others. And so we made the decision a while back that even though we spent all this time and energy, you know, updating from this to this, which was a huge improvement, we should take this and go to this, replacing Vertica with StarRocks. Yeah. So,
Were there things that weren't costs that you didn't like about Vertica?
cost was probably one of the biggest ones, but another really big one was support. We have told the people over at Vertica like exactly what needs to be done to fix something, and their response was, well, it works on my machine. Like, I don't know. We have not at all been pleased with the level of support for how much we were paying for Vertica, not to mention the cost associated with licenses for Vertica. AC.
I was just going to mention that they're not very cloud native.
They're not very cloud native.
Their deployment was very centered around VMs, and we wanted to deploy on Kubernetes and we couldn't because of how they had things set up.
They do have a way to deploy to Kubernetes, but it is still based on the VM, like their VM way of doing things. And so if I recall, it was something like you have to open up root SSH access to all of the nodes that Vertica is running on. And it was not something that we would be comfortable running in production at a, you know, publicly traded company. The risk profile was just too high. So
They've been that way for 7 years. I remember working at Domo when Kubernetes would do, and they apparently thought they could just wait it out. And they're like, no, we're not going to do containers. Like, we didn't even want Kubernetes. We just wanted containerization, and they fought that to the nail like years ago. So
yeah,
You guys don't have SSH just open on all your nodes? Is that frowned upon?
I won't tell you what we do and don't have open. Yeah. So the cool thing about StarRocks though is in a lot of ways it's very similar to Vertica. You know, Vertica has that same separation of storage and compute, stores things in object storage and then pulls down a local copy so that it can query it, et cetera, et cetera. But StarRocks is running on Kubernetes. It's cloud native. You know, we have provisioned a node pool in our Kubernetes cluster that's dedicated to running StarRocks. That is, you know, the exact shape of node that we want for our workload. There are a decent number of ways where StarRocks is not as mature as Vertica. There's a number of features that have been lacking in StarRocks, but unlike Vertica, there's active development on StarRocks. Like those features keep getting added, and so they keep narrowing the gap in a lot of ways.
What specific features were you missing, or?
One of the big things that Vertica has is this concept of subclusters. So you can completely separate your workloads and say, I want to run this workload on this set of nodes and on this set of nodes. StarRocks doesn't have that yet. I have seen some things where it looks like they want to add that. I don't have any idea if that's, you know, like where that is at in their roadmap or if it still is on their roadmap. Just seen some different blog posts and stuff. StarRocks does have resource groups. And so like within the cluster, you can say, I want to dedicate, you know, 30% of my CPUs to this workload and have them be exclusive to that or different priorities and stuff. So there is still a lot of resource management that you can do. You just can't completely separate those workloads like you can with Vertica.
Like a HIPAA thing? Do you need to do that, or?
No, we have two vastly different workloads for whatever data warehouse we're running on, and within messaging in particular. And so it's nice to be able to separate those cleanly. It's not a critical thing. Like I said, you know, it still works. It's nice. One of the things that Vertica has, their projections are really great. You can have a projection that is, you know, like you can have multiple projections that are segmented in different ways, that are sharded in different ways, and
Projection like a materialized view?
yeah, like a materialized view. That's projection is Vertica's name for that. Basically, is a materialized view. And StarRocks doesn't quite have that yet for the synchronous materialized views. So StarRocks has two different types of materialized views. Synchronous, which is kind of your traditional, like, you know, okay, as I insert new data, it's going to get updated. And then there's an asynchronous materialized view where you can join in like as many different tables as you want, and then you tell it, okay, yeah, it's time to refresh this. You know, it'll go and run that query again and build a new version of the view for you. So two very different ways to do it, both very powerful. Vertica's synchronous materialized views are more powerful than StarRocks. But like I said, StarRocks is advancing way faster than Vertica. So hopefully we see some good improvements there at some point. But so that was one of the big things that has been kind of a little bit more of a struggle to overcome, is that lack of good materialized view support in StarRocks. Their async materialized views are awesome if that is suitable for your workloads. I've tried some of those out, and you know, it does a really good job at just building everything quickly and refreshing everything. Yeah, no complaints there. I just wish that there was a better way to do some of that synchronous stuff. So, but still really awesome, honestly.
Can I ask another question?
Yeah, go for it.
I asked Paul for this,
Hey,
to specifically schedule this presentation, so I have lots.
If nobody asks questions, we're gonna get out of here early. I'm just throwing that out there.
You talked about the shape of your VMs in that node pool. What kind of nodes are you running?
So right now, So this with auto messaging is still a work in progress. So we haven't productionized this for messaging, but we have for analytic. The analytics nodes, if I recall, are 8 or 16 CPUs. I don't remember. I think they're 8 and then 32 gigs of RAM. The auto messaging ones that I'm working with right now are quite a bit beefier. We run a ton of queries through this for automated messaging. They're the GCP N2 standard 32s. So 32 cores, 128 gigs of memory. And then we also have 1.5 terabytes of local SSD attached to those for fast cache storage.
That was gonna be my next question.
Okay, yeah. So that's what we're working with right now.
That's in Vertica, right? Or is that?
That same thing in Vertica. That was actually why I chose that shape for StarRocks, at least to start off with, was because that's the same thing we're using in Vertica right now. So
Apples to apples, yeah.
yeah. That may change as we get further down this path of adopting StarRocks into auto messaging. If we find that some features of StarRocks allow us to, optimize different things a little bit better, or if we find that it's not as optimized for certain parts of that workload, so anyways, that's our starting point, was the N2 standard 32s with local SSDs attached. I've been super happy with those in the past. They provide really great performance. And since it's just cache anyways, all, the source of truth is in object storage. Doesn't matter if it gets wiped out if the node restarts or something.
How long does it take to rebuild the cache if a node goes down?
It happens as needed. So StarRocks won't pull down the data unless there's a query that runs that needs it.
You don't need redundancy on those nodes. You just spin one up.
No, and in fact, if a node goes down, what I've noticed is it has each shard is assigned to a different node, and if one of them goes down, it will reassign that shard before a new node comes up, and then it'll redistribute again. So it's pretty quick at doing that. And so it'll pull down the data that it needs, keep it stored locally as much as it can. It'll evict it when the cache gets full. There's some different policies that you can set on that, as I recall. So
You're doing 3 local SSDs rated together or something?
there's 4, but yeah, it's something like that.
Terabyte and a half, you said?
It's 1.5 terabytes. Yeah, it's 375 gigs a piece. So 1.5 terabytes is 4 of those. It's running in the GKE Kubernetes engine. So it's actually, the way that works in GKE, you attach the storage to the nodes, the local SSDs to the nodes, and Google takes care of that for you. You just request as part of your pod spec, hey, I need some ephemeral storage, and this is how much I need. And I'm pretty sure that Google has rated those together for us. So, yeah.
Have you, like what ways do you minimize API calls to GCS, and have you run into that?
Yes. So that is something on an upcoming slide, so we can talk about that now. No, that's fine. One of the things that we noticed, so we never really had this issue with Vertica, but this was something that we ran into with StarRocks, which is it likes to make lots of API calls to object storage. There's some built-in ingest tools that you can use for loading data into StarRocks, and we found that those were geared towards real-time ingest, which is not ideal if you are paying for API calls to your object storage. Because every tiny little micro batch that it tries to ingest can be potentially many API calls to your object storage. So the solution there is don't use the built-in tools, the built-in ingest tools, and large batches. Right now, with what I have running, we're inserting up to 4 gigs at a time into StarRocks. And that has kept API costs reasonable. That's the biggest solution to that problem is just, do bigger batches.
I'm totally ignorant on some of this stuff, but you have a slide where you're like, here's services and Postgres, and then we swap Postgres out for StarRocks. There's got to be, what are the conditions? Like, what are the rules about the data? It's obviously not a drop-in replacement for Postgres, right? But it's like if you have data that looks like this or fits these conditions, then it's a viable replacement. Like StarRocks could replace it, right? What if does that have to be read write only tables? Like what's going on? Or is it standard analytic stuff?
It depends on the workload that you're trying to run.
Okay.
StarRocks is not going to be good for transactional workloads. Trying to update one record at a time, first of all, your API costs running in shared data mode will be astronomical because every time you update a record, that's going to be an API call. So StarRocks and Vertica both, they're really geared towards these analytical workloads where we have a bunch of data. Maybe we have an event stream coming from another service, CDC capture from Postgres database or something. And we can take all of that data and put it into StarRocks. Say, okay, now that we have this data and it's being updated every 5 or 10 or 15 minutes, which is fine according to our use case. Now we can say, okay, where Postgres would really have a hard time querying all of this data in aggregate, StarRocks can do it very quickly. Running an analytical query to see, well, okay, I want to know, across all of our customers, how many SMS messages were sent on average each day. Like Postgres would have a really hard time doing that just because of all of the data that it would have to sort through to do that. Middle of the talk. That is Ops Genie.
So are you on call?
I am on call, but just kidding. Start watching memory limit. That's fine. Okay.
So if I understand the architecture, just to clarify, you would have your stream of small things happening.
Mm-hmm.
You've got something buffering those up into large batches,
Mm-hmm.
shoving those batches into StarRocks,
Mm-hmm.
and then ideally these are like audit events or something where you're like, we have 2 billion cloud click events or whatever that we need to track. Once it happened, it happened. We would never change them. So it's best for, is that really where it's geared towards, or always analytics stuff, I assume?
The change part isn't as important. So what we have right now, we still have these databases here. And what we've done with this architecture is said, okay, let's hook up CDC to all of the stuff, or we have an event stream coming from the service that's built on top of it, one of the two. And then in auto messaging, we take that, build up a big batch and shove it into StarRocks. And then maybe a new version comes along. Well, we can shove that into StarRocks and it will overwrite the old one. But in either case, either immutable or changing data, just being able to run these analytical queries versus the transactional ones. So that's where it shines.
All with their hybrid where it stores row and column.
I have not played with that at all. That's actually one of the things that I call out.
We'll let you keep going, I guess.
We'll come back to that.
We could just delay my question.
Yeah, no. There it is. So, I talked about shared nothing and shared data. There are some features that do not exist in shared data clusters currently. It seems that the pattern is they build the feature, it's available in the shared nothing cluster. When they get it fully production ready and it hits like actual GA, typically it also becomes available in shared data clusters. So there is some disparity there depending on how you choose to run it. So yeah, these are some of the other gotchas as well. So we were talking about API usage. That's a really big one. There's also this thing that happens in the background called compaction. If you've worked with iceberg tables, you might be familiar with this idea where every time you insert data, it actually creates a new file. And then when you run a query against it, it has to go and look at everything and kind of merge it all back in as part of the query. And as you get more and more files accumulated, that can really affect query performance. And so most things that do this sort of separation of storage and compute architecture will have a background process that goes through and merges those files over time, so that you're not trying to query 8 million. You're not trying to read 8 million files as part of the query. You'll only be reading a couple of files. So if you try to do a real-time ingest, what we found in the shared data cluster in particular is that it has a hard time keeping up with compaction. And so you can kind of fall behind in that regard, and then your query performance can really suffer. So at this point, I can't recommend StarRocks for not shared data mode, at least. I can't recommend it for a real-time ingest use case. That is something that it sounds like they're working on. Like I said, they want to introduce this concept of subclusters, and then you could have a subcluster that is dedicated to running the compaction, and it wouldn't affect other workloads, but you could dedicate 100% of some set of nodes to it. So that would be really cool to see at some point. Another thing that it doesn't have right now is centralized logging. You want to see what happens on your StarRocks node that's running in Kubernetes? Well, you get to cube exec into the pod and go find it on the disk in the pod and look at it. So it's not an ideal solution, but hopefully they make that better at some point. See.
Because it's just a file, or
Yeah, it's just a file. It just writes to a file on disk.
you can't switch it to standard out.
That I found.
You can always run a sidecar. We're getting into the Kubernetes aspect of this, and
Yeah.
do like fluid bit or something. And
That's what I've thought about is, like maybe we could have a sidecar where it, exports that file somewhere,
if you're using, depending
I
what
have those two containers already built for the tests. That one sidecar tails the error log file, and the other one, there's a log rotate as well.
Yeah.
So it just tails it out, and then it's like a regular log.
Yeah. So yeah, something like that is how I kind of thought you would kind of approach that if you're doing it yourself. It doesn't ship that way, but absolutely you can do it. So yeah. What I've also found is resource constrained clusters, specifically if your local attached storage that is used for cache gets completely full, then it doesn't like it, really. And it's specifically if you have the cache full, like it is supposed to evict stuff, but there are other processes that can run that like to use disk space. For example, and this is one of the things that I do like, certain queries, if they were to exceed the available memory for the cluster, you can have them spill to disk. They're a lot slower, but at least they finish. And if you're running a query that large, then probably you want it to spill the disk anyways. But we found that if like those two things together can fill up the disk, and if that happens, then Kubernetes can, well, the pod might just stop, the container might stop, might hit an error, or the way that Google Kubernetes engine works, it can actually start evicting those pods. And then if it's local SSD like we have right now on the auto messaging stuff, you lose all of your local cache and you start from scratch. So just kind of a, gotcha to be aware there's like if you're doing that, you just have to make sure that you have enough local storage provisioned to handle the queries that you do want to run, not necessarily to hold the entire data set that you have stored.
You said this is like separate directories, so like you could have just a not a local SSD, but like a PVC that's just a little slower for like the spillover one, and then it doesn't affect the cache or something like that.
Yeah. And if you're using PVCs, then that is what it does, is it has one PVC for the storage, one for the spill, and one for logs. If you're doing local SSDs and GKE, then it's all kind of one pool of ephemeral storage.
Don't think empty DIRs have quota ability.
Right,
An empty DIR in a pod, just an empty DIR, like volume mount in a pod.
Okay. Yeah.
Just jams it like the varlib QLED on the host. Like there's.
Yeah, if you're using ephemeral storage, like there's differences there, like that's why you should be avoiding that in general Kubernetes. But like if you're specifically running with a local SSD, like in GKE, that it's way faster. You don't always get to choose the size or anything, but it's also like throwaway, just cache.
Yeah.
That's great. As long as you don't have the shared process thing of like, there's other things that don't care about your cache size,
Yeah, and what I think, if I recall correctly, what we have seen is it's specifically the spill storage. If that fills up, then that's where we run into issues, I think. So it might not have anything to do with the cache, actually. It might just be the spill storage. So
Sounds like just competition in general.
yeah. And it doesn't handle it gracefully right now if it is trying to spill stuff and can't.
Okay. So let's take the option.
What was that?
What version are you running?
3.3. I think 3.4 is the latest, and we haven't upgraded to that yet. So it's whatever's the second to latest. So, yeah. So just going back here. So some other things that I do like. We've talked a bit about kind of some of the gotchas. So some awesome things. Synchronous materialized view is pretty slick. So you can have. One of the things that StarRocks does is you have 3 or 4 different types of tables, depending on what kind of workload you're trying to do. So you can have like a primary key table, which is, well, my data might change over time, but I want to update things as they change. And StarRocks is really good at doing that. Actually, I had a graph at one point and I forgot to put it in here, but I had Vertica and StarRocks with the exact same data being ingested into both with the same cluster size and everything. And Vertica was sitting at like 20% CPU usage and StarRocks was sitting at about 3%. So StarRocks has some optimizations around that sort of thing where I want to ingest this mutating data, but I have a primary key that I can work with. So StarRocks also has what they call duplicate key tables, where it's like, okay, maybe I want to track a history of everything over time. So we're using that too, where we say, I want to know every change that this record has gone through and when it happened. and we store that in this duplicate key table. Those are a little bit faster to insert into because it doesn't have to do primary key lookups or anything. It can just write the data to disk and be done, write it to object storage and be done. But then if you try to query it and you want to look at the latest version, it can be less performant. So trade-offs. Synchronous materialized views are really awesome because they let you take one of those primary key tables and say, well, the primary key is this, which is how the table gets sorted on disk, is based on that primary key, basically. But I have like something different or have more things that I want to sort by, probably just different things, really. And so you can have a synchronous materialized view that lets you order the data differently, and so that it is better suited to the analytical queries that you're trying to run. StarRocks updates those automatically as you insert data, so you don't have to worry about, like, okay, I have to kick off a materialized view refresh every so often to make sure that I have the latest data. It just happens as you load data into StarRocks. Does mean that if you have one of those on one of your tables, it's basically like you're trying to insert into two tables simultaneously. So trade-offs on that, obviously, as with anything, but it can really speed things up in a lot of ways. Asynchronous materialized views. So synchronous materialized views, because of their synchronous nature, they can only be built on a single table. But an asynchronous one, you can pull in as many different things, do joins, reorders, whatever the heck you want. You can also, with an asynchronous materialized view, pull in data from one of those external data lake catalogs and have a nice local copy of it stored in StarRocks. For all intents and purposes, the asynchronous materialized view is the same as just a regular old table in StarRocks. It just has a way to rebuild it on the fly based on the source data. Resource groups have also been really good. So our analytics team has run into this where they have had to limit the resources available to certain workloads, and resource groups were really good because it has made it so that we can't have, like, we have a partner API that some of our customers can use for analytics. So having the resource groups makes it so that partner API can't overwhelm anybody else with a bad query. Can't overwhelm our analytics features for everybody else, basically.
That's like a hard cap, or is it let it use other resources if there's no contention?
You can do either. So you can set up like these cores are exclusively for this resource group and nobody else can use them, and the resource group can't use anything else. Or you can set kind of a priority, like if the node is, if the nodes are fully loaded CPU wise, then it'll dedicate, 30% to this resource group and 70% to this resource group, or something like that. And then if one of those kind of lightens up a little, then the other resource group can start taking advantage of it. So you can do both of those. The load and ingest capabilities. So despite the real-time load issues that I was talking about, actually loading the data into StarRocks is pretty quick. So I'm sending batches of about 4 gigs right now. That's what they're, so we're sending it over JSON right now. And if you do more than that, their JSON parser kind of throws a fit. But other than that, like handling a 4 gig batch, it does it great. So we can load a couple of terabytes into StarRocks relatively quickly. So Storage and compute separation. So this is awesome, you know. We have in auto messaging, we want to be able to look back at the data that was used to produce a message. You know, maybe somebody calls into Weave and says, hey, this message was sent and it shouldn't have been, or this message wasn't sent and it should have been. Well, we can look back at the state of the data at the time that we tried to send that message and say, well, this is why it was or wasn't sent. You know, we can look at that history, but those are very ad hoc queries. We don't do that particularly often. And so most of the time, that stuff just sits in object storage, not really doing anything, and it's cheap. So that's really nice. And then also, as I mentioned, the data lake capabilities, being able to hook it up to Iceberg and GDBC stuff. So one of the things I've been exploring is just, you know, when we have all of the data that we care about in our data lake, well, to do an initial load into StarRocks, we can just hook it up to the data lake and say, well, StarRocks, just copy it over from the data lake, done. Now you have a local copy that we can start building materialized views on, start building other indexes on, that sort of stuff. So it'd be super fast. And we can query other data in the lake and join it to data that we have in StarRocks or in other places at Weave and do some really cool analytical queries and stuff like that. So,
Did you think about storing the data natively as Iceberg versus StarRocks native?
We've thought about it. The main reason that we haven't done it is just because of the flexibility afforded if we store it natively in StarRocks. We can create additional indexes and additional materialized views if we do it in StarRocks.
But you can't make a materialized view off of an Iceberg table?
You can do an asynchronous materialized view, but not a synchronous one. So that's why we went that route. I can totally see use cases where that would be totally fine. You know, like, hey, I just need to refresh this data once a day, like 100%. If it's in Iceberg, well, just do a materialized view that refreshes nightly. Like, that can be super powerful and super flexible. So. Okay, and then wrapping up. So some things that I'm looking at in the near future, hopefully. So auto scaling, it does support auto scaling on Kubernetes. You can scale it based on memory usage or CPU or whatever else. I don't see any reason that this won't work. They advertise it as a thing, so it should be fine to introduce auto scaling. And then the other thing I want to look at is these preemptible nodes, because you can get some serious cost savings with spot instances. I suspect, though, that we wouldn't be able to do this unless we have like dedicated subclusters and what, you know, some workload that is not latency sensitive on a subcluster of spot instances, so that we get cheaper infrastructure, but maybe we have slower queries every once in a while.
Why would you think it'd be slow? It feels like if you're in spot instances, the fear is that the thing just goes away.
It goes away, which means that the remaining nodes, have to pick up the slack,
Okay.
and then a new node comes online, and until its cache is, kind of warmed up, things might be a little bit slower.
Okay. So it's
And
not.
there's no guaranteed availability.
That too, but there's ways around that too. So
You split it, right?
you can split it and say, well, if there's no availability, then spin up an on-demand node for now and then migrate it later or something. That's what we do for a lot of our stuff.
How do you do that?
You'll have to talk to somebody other than me about that one. Sorry. I don't know how all that works. So
We've got an entire internal service whose job it is to kind of redistribute load. It's the rescheduler before Kubernetes had a rescheduler. So not public, but we've got something that goes on there and tries to move stuff around.
So what is it about StarRocks specifically that results in cost savings over Postgres?
Depends on your workload. So.
For your case.
Yeah, so the biggest thing is gonna be that StarRocks is a columnar data store. So it's really good at those analytical type queries. And then also that we can scale storage and compute separately. Those two things kind of provide the cost savings. And then maybe at some point, spot instances could also provide could provide cost savings.
With Postgres, you're just locked into vertically scaling whichever instance you have.
What was that?
With Postgres, you were just locked into scaling that.
Mhm. Yeah, like if we wanted to scale up something, like if something gets too big for Postgres, then well, you have to split that onto multiple Postgres servers, and you can't easily go back to fewer Postgres servers. And also, like, to handle the same workload that we're trying to do, same analytical workload specifically, takes a lot more Postgres than it does StarRocks.
Have you looked at the GCS Anywhere cache?
I'm not even familiar with it.
It's like an infinitely scaling. It sits in front of GCS and it's a local SSD in your zone. And it's like a read-through cache that works like the,
Interesting.
so you
Okay.
could share the one GCS read across however many shards.
That could be interesting. I'll have to look into that. Yeah.
You point your object store clients at the cache.
No, it's magic.
Okay.
Like,
Oh, 'cause we're
Google,
going to their
it's a
host
Google
names.
product that
Yeah.
intercepts the call. It scales infinitely. It's not like a provision store. The only knob you have is what's the TTL? And do you want to cache it on the first or the second read?
And then they're doing something behind the scenes of like, oh, when you go to this host name that's normally the storage,
They're checking,
Yeah, okay.
Okay.
filling it, and it's a synchronous, it's strong and consistent.
What's the pricing like on that?
I have a thread in Slack for like I'm looking at StarRocks and or DuckDB, and that feels perfect in front of us. But I was like, do I run one mega node with a mega local SSD so that I don't have as many slow hits? But that one is running on essentially like a persistent disk. But you don't have to manage eviction or whatever.
Yeah.
Or throughput.
I have to point.
The scale is hard. Like, it doesn't have to write anything, I guess.
It just does. Well, it has, as much throughput as Google has hard drives.
You can't scale it. There's only so many atoms.
Well, as long as you stay smaller than Google, you're probably okay.
All right.
Good deal.
Too small.
Yeah, we have bigger ambitions than that. Let me tell you.
Big.
All right, well, cool. Well, that's it.
Oh, I have another question. Have you tried the auto classing for GCS?
We haven't. Everything is on the
Standard.
standard. It doesn't. Yeah, we don't for the StarRocks stuff. We don't pass that down at all. Haven't looked at that really. That
Do you
could
have
be
any
interesting.
concept of like how old, like your older stuff that really doesn't get touched?
I don't know. That I'd have to look into that and see. Yeah.
How does auto classing work? Is that just something you turn on in GCP?
Yeah, you just turn it
go to the
on.
It's kind of like a new age object lifecycle management. And if it hasn't been read for 30 days, they class it down. And there's no penalties for upclassing. You're paying a per object fee. So it just switches but if you're in a data lake where your files are, hundreds of megs or gigs, your number
It's
of.
pretty cool. I just don't know, like, I don't know how often StarRocks is reading all of the files. So I'd have to go and look into that and see when the last time each of those was touched. See if it would auto-class it at all.
I was chatting with the BigQuery team about their managed Iceberg. And they said that it should still work fine with auto classing enabled. So there's not any latency penalties.
We'll do that.
One more, right?
And